terminating, non-terminating, and recurring decimals. Fractions can be converted to decimals by dividing the top by the bottom, the numerator by the denominator. We can do that with a calculator, or we can evaluate it by using the division algorithm. Now I'm going to leave these two for a moment and just show you 2 divided by 7, and I get quite a long decimal number there. 0.285714286, and I happen to know that that one keeps going. Now what I mean by keeps going is sometimes a decimal can be evaluated and just stop. We run out of remainders. So I'll use 1/4 as a reminder of how to evaluate by dividing. This is 1 divided by 4. 1 divided by 4. 4 into 1 doesn't go. I would normally put a 0, but this is only 1, so I need to put 1.0. Put my point there so I don't forget it later. 4 into 10 goes twice with 2 remainder. Put down my next 0. 4 into 20 goes 5 times with no remainder, so this is 0.25. It just ends. It doesn't keep going, there's no remainder there, and this is what we call a terminating decimal. So terminating decimals have a limited number of decimal places. They stop. Terminate means to stop. Now, if I was to divide out 2 divided by 7, I would discover that there was a remainder here, and there'd be a remainder on the next one, and I'd just keep going. The same thing happens with 1/3. Now, while you're most welcome to use a calculator to get this answer, you do need to be able, for a B grade or above at the moment, to divide this out and show me. So let's do 1 divided by 3. 3 doesn't go into 1. Put down my decimal points, put in a 0. 3 into 10 goes 3 times, remainder 1. Put down a 0. 3 into 10 goes 3 times, remainder 1. Put down a 0. 3 into 10 goes 3 times, remainder 1. Look what happens. Nothing is ever going to change. That is going to keep going and going and going as 3s, because there's no change that can possibly happen. I'll always have a remainder of 1. This is a non-terminating decimal because it never ends. And our non-terminating decimals can fall into 2 parts. These two are both what we call recurring decimals. They fall into a repeating pattern. It's never ending. So this will just keep on being 3s all the way down. This is a recurring decimal. And this one may look like it isn't, but this number here has been rounded, and the recurring part is 285714, 285714, 285714. One trick is that recurring decimals come from fractions, as do terminating decimals. These come from fractions too. And any fraction is going to divide out either to a terminating decimal or a recurring decimal, they're never going to divide out ever to what we call a non-terminating, non-recurring decimal. These do not come from fractions. No fraction will ever make one of these. It's either going to stop or make a pattern. We get our non-terminating, non-recurring decimals from things like square roots. Now some square roots, remember a square root is saying what did I square to get this number? So I know that, for example, 5 squared is 25. So if I do the square root of 25, it's saying what did I square to get 25? So the answer is obviously going to be 5. That's fine. But sometimes I say, well, what about the square root of 2? Now you can't think of a number that that multiplies by itself to give 2. 1 times 1 is 1, 2 times 2 is 4. It's got to be somewhere between those two. The square root of 2, now when you get that with your calculator, just put the double arrow saying I really want a decimal please, is 1.414213562, and it just keeps going. And we show that it keeps going like that, and if a square root doesn't stop nicely, like that square root of 25, chances are it's going to keep going and going and going. It's never going to stop, and it's never going to start falling into a pattern where we can say, okay, it's just going to keep doing the same thing from now. Pi is a very famous number that's another one. Pi equals pi, thank you calculator, push this for a decimal, 3.14159, it just keeps going. Etc. It doesn't come from a fraction, it's just its own number, pi, and it is non-terminating and non-recurring. So there's 3 types of decimals. The 2 that come from fractions, recurring decimals and terminating decimals, and the ones that don't come from fractions. They don't end and they don't start repeating patterns. We'll talk about the name for these later on. So you do need to be able to tell me if a decimal is terminating or not, and if it's not terminating, is it recurring? So the really easy ones are these 2. They're terminating because they just stop. We can tell because there's no dots after them. In a question in a test, to show that it keeps going forever, they'd put dots or write it in a particular way, which I'll talk about later. So these 2 are terminating. These 2 are not terminating. Are they recurring? This one is. It's fallen into a pattern of 6s. So I've got a recurring decimal, 3.14159.265. If you were looking very carefully before, you'll see that's pi, Pi, and that's its symbol. And it will never form a recurring pattern. Because I can't see a recurring pattern here and I can see that it keeps going, I just say not terminating. So this one is not terminating and it's not recurring. These 2 are terminating, this is recurring. We do need to be able to write recurring decimals because it's annoying to have to write 0.66666666 forever. And annoying to, I've forgotten what I was going to say, sorry. So when we write recurring decimals, we cut them off after one set of the repeating pattern. So for this one, the repeating pattern is 1, 1, 1, 1, 1. I'm going to cut that off after one copy of the repeating pattern, which is there. So I'll write 0.1, and then the notation is put a bar, over the whole repeating pattern. on the one that you just rewrote. So the whole repattern is only one, I put a little bar over it. Here, 23.389999, the repeating pattern is 9. But I have to write everything up to and including the first part of the repeating pattern, 23.389. So I'm cutting it off there, so I'm just giving one part of the repeating pattern. You must rewrite it. You can't just go, oh, I'll cut it off there and put a bar. Nope. Bar over the repeating pattern bit only. 1.232323, the repeating pattern is 2 and 3. Cut it off and rewrite it, 1.23, after one copy of the repeating pattern, and put a bar over the whole repeating pattern. 0.01234, the repeating pattern is 1, 2, 3, 4, so I will write 0.01234 and put a bar over the repeating pattern. Now some versions do put a dot over start and end. So I'd put a dot there, I'd put a dot there. Here I'd put a dot above each one. Now it looks like a face. Here I'd put a dot at the start and the end, but that's harder to remember. So just saying put a bar over the whole repeating pattern is fine. But we do need to know the dot notation because here it is. The last thing I do need you to be able to do with the recurring decimals is to write them correct to 2 decimal places. This says 0.6 recurring. That's 0.666666, etc. Write it out with a few copies of its repeating pattern and then round, in this case, to 2 decimal places. Cut it off after 2, look at the critical digit. Yes, I have to round up because it's more than 5, 0.67. To write this one correct to 2 decimal places, that's 3.24812481, etc. Cut it off after 2 decimal places. Look at the critical digit. Yes, I have to round to 3.25. So a long video there, I'm sorry, but we've gone through quite a lot in the way of decimals and different types.